Hey everyone, welcome to Grid Driven Math and Physics. And so we're looking at a circuit problem. It says in the circuit shown below, three resistors X, Y, and Z are connected as in a diagram. So the diagram you're looking at is this one. It says X and Y are connected in series and then in parallel with Z. A 20 volts power supply is connected across the combination. A current of 40 amperes flows through resistor X as shown there. Okay, when they're saying given the current through X is 4 amperes and total voltage is 20 volts, calculate the potential difference across X and Y. Okay, so part one is this one. It says the potential difference across X and Y. So we know that potential difference for X and Y, that one is simply 20 volts. That one is equal to the total voltage of the supply. So, okay, so that is done right there. Now, the current through Z, okay, current through Z. Now, to solve this, you can't do it without first of all assuming something, okay, and what you have to assume is that these resistors are identical, okay? So from there, if that is the assumption we're going to make, that means the voltage on X should be equal to the voltage on Y, which is equal to voltage of the supply divided by 2. That's 20 volts divided by 2, giving us 10 volts. Sorry about that. 10 volts, okay? If that is the case, that here there's 10 volts and here there's 10 volts, this tells us here that we can find the resistance of the resistors X and Y. So we just have to find for one. So Rx will be equal to voltage at X divided by current at X. That will translate to 10 volts divided by 4 amperes. This gives us 2.5 ohms. Okay, so if this is the resistance, from there we can also assume, because these things are identical, that means Rx is equal to Ry equals Rz. That gives us 2.5 ohms. Okay, so from there we can now try to find the current through Z. First of all, though, we have to understand that this voltage from the supply is equal to the total voltage on this branch and total voltage on this branch. Okay, so that means voltage on Z is equal to voltage from the supply, which is equal to 20 volts. Y is the only component in that branch. All right, so it will be equal to the voltage from the supply. That is a rule for parallel circuits. Okay, so from there we can work out, we know the resistance of Z, and also we know the voltage of Z, so we can calculate the current that is flowing through Z. That's voltage from Z equals resistance of Z. That's 20 volts divided by 2.5 ohms. This gives us 8 amperes. So what you're seeing here is that since the resistance on this branch is double, okay, so the current here will be double than the current through that. Why? Because on this branch there's more resistance and it is by 2 times 2. Okay, so that's why there will be a doubling there on the other branch. So from there they also want us to find, so we've done this, and then now each resistance we've also done it, and then they want us to find the power dissipated by resistor Z. Okay, so when you look at Z, it's right here. We have found a couple of things concerning Z. Okay, we know the voltage, the current, we also know the resistance. So now if we're going to find power, we can use either formula. Power is equal to voltage times current. So the voltage we're using is the voltage through Z multiplied by current, 8 amperes. This gives us 20 multiplied by 8, that is 160 watts. Okay, so that is the power dissipated. Alright, so if they want us to find the total energy dissipated by the circuit in 10 minutes, the energy is equal to power times time. Okay, so from here, energy will be equal to the power in the circuit. Do we know it? We don't. So we will say VIT. What we found here as the power is just for Z, okay? But here they're looking for the whole circuit. So energy will be equal to the voltage of the whole circuit is 20 volts multiplied by the current for the whole circuit is 8 amperes plus 4 amperes. That's the total current. So for those who are not understanding that, remember, on this branch there's a flow of 4 amperes, and on Z we actually found that there was 8 amperes. That means the total here will be 8 plus 4. That's the total current in the circuit. So this multiplied by converting the time to seconds, that will be 60 seconds. This will give us 20 volts multiplied by 12 amperes multiplied by 600 seconds. Okay, so we'll do 20 times 12 times 600. That gives us 144,000 joules. That's the electrical energy that is converted by the circuit. So the key word here is circuit. I hope that makes sense to you. So this is it for this problem, and this is what you're required to do. Check against the solution that you found and see if you did the correct thing. Until next time, have a good one.